Our next guest is a Notre Dame PhD candidate from the College of Engineering. Robert Devine was a member of the Notre Dame team that won the national Big Beam competition, a beam design contest judged by the Pre-Stressed Concrete Institute that challenge, design, fabricate, and test a concrete beam. So, Robert, welcome to Notre Dame Day.
Thank you for having me, Maureen.
Glad to have you here. Before we get started to talk about concrete, where are you from and why'd you decide on Notre Dame?
Absolutely. So I'm originally from the Jersey Shore. I went to Notre Dame undergrad. I graduated in 2015, and then I continued my PhD studies here for probably two important reasons. One, the Notre Dame community. I really feel like both the graduate school and the undergraduate school really tries to put up their students for success, whereas in a lot of other places you can be one in a big pond. And then otherwise, I chose to stay at Notre Dame because of my research interests. My advisors, Dr. Gino Karama and Ashley Thrall, are both on state-of-art research projects looking into innovative and sustainable reinforced concrete design for seismic hazards, and then also rapidly deployable construction practices, both of which are really things that I'm interested in, ended up lining up well.
Every time I drive by or under a bridge or see a big building, I wonder about it. How do you go about building a beam? Where do you start with the design?
Absolutely. So to boil it down, there's two major criteria. First, you have the structural demands. So those can be seismic loads, wind loads, dead loads, so from cars, or just the weight of the structure. And then you'll have your stakeholders criteria. So both your owners, making sure it's the most cost effective. A lot of times architects in buildings, they want to make sure they have very small story heights, so you may have to make your sections a little bit smaller. So essentially you're weighing back and forth, how do you make this most cost effective and then also meet the loads and demands of the structure. So.
Okay.
Yeah.
So you didn't just draw this on paper with 3 calculations.
No.
Tell us what you had to do.
No. So it's a 2-semester long project.
Wow.
Where this class is a little bit different than any of the other design classes that we do. So the first semester is spent figuring out how the design nuances are different for pre-stressed concrete. So up until the Thanksgiving break we learn how design of pre-stressed concrete works and then try to finish our design by November. And then from the end of that semester and the beginning of the semester, we work on the construction of the reinforced concrete beam and the mold that we'll basically pour the concrete into. And then we bring it over to a precast distributor in South Bend, actually up the road on Route 23. It's Stress Core Inc. And we'll cast the beam there, bring it back to Notre Dame, let it harden and gain strength over 28 days, and then we'll test it. And then after that, we have to write a report and submit that to the Precast Concrete Institute. So it's a long project.
How do the judges select a winner?
So there's some hard things that you have to meet. You have to meet some load criterias, that the beam has to be at least this strong, but you can't over-design it. So you basically have to hit a range, and you basically say, this is what we designed it for, and you have a % error there. You design it for the least cost, least weight. And then there's some more subjective things like, is it an innovative design and is it a practical design? Which a lot of the times those are a little bit conflicting. You want to make sure you're innovative, that you're pushing the envelope, but if you go too far, it's not practical for people to use. So in our design, we tried to push the envelope on how small the concrete section was, which ran into issues of could we actually fit our hands into some of the places we had to construct. And then we also used innovative materials, so we used high-strength concrete, so that was one of the ways that we improved our design from previous years.
Fascinating. Thanks for being with us today. We really appreciate it.